This is 2012 ABFRQ number 5. So this comes on the heels of the 2011 AP test, in which they had a question very similar to this, and over half the students got it wrong. So obviously this is tricky to a lot of calculus students, so we're going to pay special attention to this one. So we are going to pick out important information, but this first statement right here, very wordy, and I'll kind of explain where that is located. The rate, so that rate there, derivative, at which the baby gains weight. So it's the rate of the weight of the bird, and they call it B. With respect to time, so that is how fast the weight changes as time changes. So the rate at which the bird gains weight is proportional to. That word proportional to means it's equal to something plus a constant in front. So something and a constant. What's that something? The difference means subtraction between its adult weight and its current weight. Well, its adult weight's 100. The current weight is B. So here's your constant, and here's your adult weight minus current weight. So in actuality, this is that opening sentence. So we are going to pull out all the important information here so I don't keep reading this statement over and over and over. It's important to annotate it at the very beginning. And that way you don't have to keep on trying to reread it. Next statement. At t equals 0, so I'm going to put that down in my information. When t equals 0, when the bird is first weighed, its weight is 20 grams. So weighs 20 grams. So I've taken care of that statement. So keep moving. B of t is the weight of the bird. I'm going to write that down. The function b of t is the weight of the bird. Now I'm not going to write bird because that's the only thing we're talking about. I don't have to worry about any other weights, so I don't need to do that. T is the days after it's first weighed. To me, that's so obvious that I'm not even going to write that down. Grams, that's something you might want to put down, especially if it asks for units. So I'll put in grams. All right, part A, here we go. Is the bird gaining weight faster? So faster implies the rate at which it's gaining weight. So as we look at this, we should see that as the rate of gaining weight. dB means change in weight. dt is change in time. And you're comparing the change in weight over change in time. That's how fast the weight is changing. So is the bird gaining weight faster when it weighs 40 or 70? It wants to know the derivative at 70 and 40. So we're going to find the derivative at 40. And we're just going to plug 40 into that equation. That's 1/5 of 60, which is 12. Now, you don't have to write 12. You could stop right there. Because if you divide that incorrectly, no bueno. So we're going to find dB dt when b is 70. Just plug it into our formula we're given. That's 1/5 of 30, which is 6. So understanding what this means it gains 12 grams every day as opposed to 6 grams every day. So clearly, when is the bird gaining weight the fastest? The bird gains weight the fastest, or faster, because we're comparing 2 days. Faster when it weighs 40 grams. Now, you have to give a reason. You can't just make a statement. All FRQs need to be backed up with calculus. So we're going to write because, and there's a reason, because that's bigger than that. So we're going to say the derivative at b equals 40 is greater than the derivative at b equals 70. And that's part A. We're going to go to part B now. Okay. So we want the second derivative. Well, we take the derivative of the first derivative to get the second derivative. So I'm going to write down the first derivative. And this is where a lot of people make mistakes. Here's a common error. Don't do this. They'll say, oh, that's easy. I'll take the second derivative by taking the derivative of both sides. 1/5 the constant. Derivative of 100, 0. Oh, derivative of minus b? That's just minus 1. Because the derivative of a variable is just a number in front, right? Wrong. Be very, very careful. Notice our variable is t. This is not our variable. What is b? B is a function of the weight of the bird. B is a function of time. So when you look at b, you treat it as a function, not as a variable. So what is the derivative of b? Well, it's db dt, because that is the derivative of b with respect to t. Now we're not quite done because they asked for it in terms of b. I need to write that as b's, not db's, but we know that equals 1/5 100 minus b, so we're going to replace it with that. So we get 1/5 minus 1/5 100 minus b. There is the second derivative. We do not have to simplify that. You could just leave it like that. I'm going to simplify it just because I feel like it. But on the test, if you do something wrong and you multiply wrong, you're going to lose that point you already had. So now they make a statement. Check this out. Explain why the graph of b cannot resemble the following graph. They're telling you this is an incorrect graph. And you have to explain it using the second derivative. So automatically in your head, you have to think, what does the second derivative tell me about the graph of b? And you should immediately think concavity. So you should think there's something wrong with the concavity of this graph. Now, if you look, the first half is concave up, right? The second half is concave down. So how is our answer not fitting that? Well, what is this, positive or negative? And you might look at that and you're like, I don't know, depends on b. If b is bigger than 100, this will be a negative and a negative, make a positive. If b is smaller than 100, that's going to be positive and a negative, make a negative. So that's where you have to look at your information. Here is the weight of the bird. Clearly, it's between 100 and 20, right? So you need to state that. Since let's see, b is between 100 and 20. 3 dots like that means therefore. Therefore, the second derivative is going to be negative. You can write less than 0, or you can say is negative, because if b is, or equal to, I should say. So since that's true, if b is smaller than 100, it's going to be negative. If b equals 100, it's going to be 0, because that's negative in front. Well, if that's true, what does this mean? A negative, whoa, let me undo that. Not sure what just happened. So a negative second derivative gives you concave down, right? But 0 means neither concave up nor concave down. Could be an inflection point possibly. But this can't be concave up. Okay? Cannot be concave up because it's never positive. But our graph is concave up for the first half. So you should say, therefore, another therefore, because the second is negative or 0, Therefore, B cannot be concave up. That's your statement. But look at your graph. The graph has a concave up section, right? The given graph has a concave up section or portion, however you want to say that. Therefore, the graph is incorrect. Or you could say doesn't match or can't be the correct graph. However you want to state that, you have full freedom on that, okay? Now, I'm going to do part C. I'm having issues here. Let me erase all my previous work. I need some space here. Hopefully I can erase this without losing okay, look like it's working without losing my borders or my white background. Okay, so part C. So they were nice to you. The previous year, they did not say use separation variables. They won't always say that. Sometimes it just says find the particular solution. That's all it will say. So you have to recognize separation of variables. So we're taking dB dt is this. And we need to find the particular solution. That is the value of the function b, or not the value, or the function b, where if we plug it in here, it will be true. It will make this equation true, or makes the equation correct, however you want to say that. So how do you do this? Here's a mistake a lot of people make. They go, oh, that's easy. The antiderivative of b is b squared over 2. But again, you're not paying attention because the variable is t, not b, so you can't do that. And here's your hint of separation of variables. This is my function. Whenever your function appears in your derivative, you have to separate your variables. So we're going to divide both sides by 100 minus b. And that's going to get those to cancel out. And that's how we get this part. That dt, we're going to throw on the other side. And you'll get 1 point for separating the variables like that. That's 1 point down. Okay? Then we're going to continue going. Integrate both sides. The right side is super easy. 1/5 t plus c. So in this particular year, they gave you a point for putting plus c. Pretty generous. For finding the antiderivatives, they're going to give it 1 point. But on the left side, I have a problem. I need to do a u sub. Because if this down here were just a b, antiderivative of 1 over b is ln absolute b. But that's not b, it's a function. So I need to replace it with a single variable. But the top, I need a du. That's going to be minus dB. Do I have a minus dB? Now I do. So the minus dB on top becomes du. The bottom becomes u. And this is pretty easy. The antiderivative would be absolute value of u, ln. And replace u with the original, which is 100 minus b. And I get this. So you would have received 1 point for the antiderivatives and 1 point for the plus c. They don't give you the plus c point anymore, just to let you know. They were too generous in the past. They don't do that. The next thing, we can find c now, or we can isolate b, then find c. You can do it any time. I'm going to find it right now. So they tell us right here that b of 0 is 20. In other words, when t is 0, b is 20. I'm going to plug that in to this equation here. So let me copy and paste that. Oh, I see what it's doing. I don't know if I'm going to be able to pull this off. Nope, it's going to hide it behind it. So I'm just going to rewrite that. So since this is a point in my solution, and this is my solution, I should be able to plug it in. T is 0. Well, that's just 0. I don't need an absolute value because 80 is always positive. There is my C. Now you would receive a point for finding the C. And you could find it later. It will come out kind of different, but it will be correct. So I will take that answer and plug it in for C. So there's 1 point left. That last point is solving for B, because essentially that's what they asked for. They wanted us to find B. So to solve for B, I got to get rid of that, I got to get rid of that. So first that negative sign, I'm going to multiply both sides by negative. I'm going to get a positive, negative, positive. Then to get rid of ln, I e both sides. E and ln are inverse functions, leaves me with 100 minus b. And I get e to the negative 1/5t plus ln 80. This is, I can rewrite this, and here's where you need your algebra skills. Exponents with the same base, you add the exponents. Well, if I add those, I get that. So that's equivalent. And e and ln cancel, leaving 80. So I get this. I'm going to put the 80 first, and that part second. Now I have a problem with the absolute value. I need to get rid of the absolute values here. Well, one way is to observe that b is always less than 100 or equal to. So I don't need the absolute value. That would be the fastest way you could explain that. Since b is less than or equal to 100, I don't need the absolute value. But the other way, and this is the more general case that works in other situations we're not given that, I need a plus or minus. But remember your statement, b of 0 is 20. Well, if I put a 0 here, e to the 0 is 1, and I put a 20 here, obviously which one do I need, the positive or the negative? Well, it equals positive 20. So positive 20 here, 100 minus 20 is positive 80. I need the positive. Therefore, b of t is 100 plus 80 e to the negative 1/5t. All right, I think that was the last question. Let me take a look real quick. Oh, back up a little bit. I don't know what I'm doing. If I isolate b of t, that moves b of t on this side, and the 80 be subtracted, so b of t would be 100 minus 80 e to the negative 1/5t. But we do eliminate the minus because that makes it work. And then you solve for b and you get that. That's our final answer, and I'm sticking to it.